Welcome, pre-algebra students, to our video on multiplying fractions. So I'm at school, and it's before school, it's early, but the PA might come on, so I will try to pause and re-record any sections that might be obscured by any announcement over the PA. Anyway, we're multiplying fractions and mixed numbers now, and we're still doing review. This is stuff you have covered before. Whether we are comfortable with it or not depends, but we have covered it before. Last year you saw these area models. So this is one whole, this square, and this is like saying 3/4 times 2/3. So let's look at what we're actually talking about when we multiply fractions. All right, so let's get started. All right, when you multiply a number by a fraction, why is the answer smaller? Well, in order to talk about that, I want to start off with thinking about the identity property of multiplication. The identity property of multiplication. The identity property of multiplication says that 1 times a is equal to 1. So let's use a of 3. 1 times 3 is equal to 3. 2 times 3 is equal to 6. So the bigger the multiplier gets, the bigger the product. That's what we learned. That's what we learned multiplication is. And then fractions come along and ruin everything. Because when you multiply by a number smaller than 1, your product is going to get smaller. But that actually should totally make sense. Let's make it a fraction, 1/2. Or how about 1/3 times 3? That's 1. Or how about 1/6 times 3? That's a half. So you can see that these numbers, as your multiplier gets smaller, these products get smaller. So that should help make some sense of this, because it's counterintuitive that multiplying gives you a smaller answer. Because you learned multiplying gives you a bigger answer. That was the overall big idea that you learned in the first place. So just some food for thought to try to help us make sure that we can wrap our brains around what we're actually doing. All right, to multiply fractions, rewrite any mixed numbers as improper fractions, multiply numerators, multiply denominators, remember the rules for signed numbers if you've got positives and negatives, and then simplify. All right, so in this case, we can do that. We don't have to worry about signed numbers because they're both positive. Multiply numerators, 1 times 2, 2. Multiply denominators, 6 times 3, 18. Simplify by dividing both numerator and denominator by 2, 1/9. Easy peasy. But, those are nice small numbers, aren't they? And remembering to simplify can be a challenge, not so much here because they're both even, just cut them in half. But it can be a challenge. So in order to alleviate that challenge, simplify before you multiply. Here's an example where it makes the numbers smaller and more manageable. 88 75ths times 25 99ths. Yes, I wrote it that way on purpose. If I don't simplify, I have to multiply 88 times 25. I don't want to do that. But if I take both of these numbers here diagonally and I divide them both by 11, I'm left with much smaller numbers. And if I take both of these numbers over here, switching colors to see the difference, and I divide both of them by 25, I get a 1 here and a 3 here. Again, much smaller numbers. So when I finish the problem, I get, I'll go back to the blue. I get 8 over 27. Much nicer than multiplying 88 times 25 and 75 times 99. Now, why are we allowed to do this? Well, let's remember what's happening here. This is why I can do this. So this is what's really happening when we multiply. Now let's use the commutative property and switch the 99 and the 75. Now if I can put those together like that, how about I take them back apart? So really all I'm doing when I simplify diagonally, it's like I'm simplifying vertically, because look what happens. 8, 9. Oh, that's not supposed to be a 27, it's supposed to be a 25. Please excuse the typo. 1, 3. Okay, so that's why we're allowed to do that. Let's try some problems. We're going to do 3 together. You're going to do 2 on your own, 2 quick word problems, and we're done. Okay, so in this circumstance, I do have to look at my rules for signed numbers. 1/2 times -6/7. So positive times a negative is a negative. I'm going to multiply straight across the top, 6, straight across the bottom, 14. And then I need to simplify by cutting them both in half. -3/7. Not difficult, not complex at all. Okay, how about down here? Here's a good example of where my being able to simplify diagonally is going to help my laziness. I don't want to multiply 12 times 20. I'm too lazy. So let's divide both of these numbers by 5. And let's divide both of these numbers by 6. And then let's remember it's a negative times a negative, giving me a positive. 1 times 1 is 1. 2 times 4 is 8. All right, next. Mixed numbers. Mixed numbers are complicated and annoying because it looks like it's two pieces of number. And when we write it as a mixed number, that's the practical size. When you're making a recipe, you say, I need 2 1/3 cup of flour. You don't say, I need 6 plus 1, 7/3 cups of flour. That doesn't make sense. Okay, so the mixed numbers are really just for a practical sense, for being able to talk about the math when we're actually thinking about things, objects, recipes, stuff, rather than the actual computation where that stuff's not important because we're just multiplying here. So again, multiply, add, 14 plus 5, 19 sevenths. Is that right? Yes. All right, good example of a place to simplify. So I'm going to simplify by dividing both of these 7s by 7, leaving me a 1 and a 1. 1. Giving me 19/3. Now, because the problem gave me the answer in a mixed number, I should go ahead and convert this to a mixed number. 3 goes into 19 6 times. That's 18. 6 times 3. So there's 1 left over. 6 1/3. Now, if you're typing into an SOL test, you probably are going to end up putting an improper fraction, although you'll see that more in algebra. But you should be able to recognize both answers. All right, it's now your turn to try a couple of problems. So I want you to copy these down, pause your video, and try them out, and then I will go through the math with you on the screen. So go ahead and pause your video and try these problems out now, please. Okay, here comes the answer for 1. And there we have it, negative 7/12. We cancel, or we simplify, I should say. You can also say canceling if it's the same number, because they do just basically go away and become 1s. But in this case, we're simplifying, because we got a 3 here. Divide 9 by 3, we get 3. Divide 3 by 3, we get 1. Multiply across the top, multiply across the bottom, finished. Okay, here comes the next one. And we get negative 5 for this one. So improper fractionize it, multiply, add. Remember, we went over why we do that in class. So multiply, add. Now here we get 9 halves. Here we have negative 10 halves. Please do not think of this as a negative 1 and this as a positive 1/9. That's not the case at all. Remember what this number is equivalent to. Good chance to review our repeating decimals. Is negative 1.1 repeating. So that value is the same. It's easy to remember this is one value altogether. It's harder to remember this is one value altogether. But when you put it into the improper fraction, remember it is still negative. So we're going to simplify here. We can cancel the 9s because we get 1s. We can divide these by 2. We get a 1 here, a 5 here. Positive times negative is a negative. 1 times 5 is 5. 1 times 1 is 1. And we're not going to leave it like this. Please rewrite it like this. Okay, we're not going to leave that. We don't need the over 1. We shouldn't put the over 1. Just put negative 5. All right, 2 application problems, and we are through with multiplying fractions. Dexter's lawn is 2/3 of an acre. If 17.5 bags of fertilizer are needed to treat 1 acre of grass, how many bags does Dexter need? So he has 2/3 of an acre. If he had 1 acre, we would say 1 times 17.5 because he has 1 bag. So the need for 1 bag is 1 times the amount of bags it takes to treat 1 acre. So here we're going to do 2/3 times that number of bags. It can often be difficult to figure out what we're looking for in these problems, whether it's multiplication, division, etc. Look for this word. 2/3 of means 2/3 times. We'll see that some when we translate expressions, but you can see that here in this word problem. So we have 2/3 times, let's make it an improper fraction. So we're going to multiply, add. So 2 17s. Remember, 2 17s, think in your head. 2 10s, 20. 2 7s, 14. Put it together, 34. So 34, oh, except it's not 34 because we then have to add that 1 right here, this 1 right here. So 35 over 2. We can simplify the 2's or cancel the 2's, get 1's there. 35 over 3. And since this is a practical application, we're not going to leave it 35 over 3. I need 35 over 3 bags of fertilizer. That sounds ridiculous. 3 into 35 goes 11 times with 2 left over, 11 and 2/3 bags of fertilizer. Even better, we should probably write it in a sentence. So do that on your paper. Dexter needs 11 and 2/3 bags of fertilizer. Last problem. Joyce is making her gingerbread recipe for a party. She needs 2.5 teaspoons of vanilla for the recipe. If she is making 3.5 times as much as usual, how many teaspoons of vanilla will she need? So again, she's making 3.5 times as much. So we are multiplying 2.5 times 3.5. Think we'd use the 2.5 once if we were making one batch, but she's making 3.5 times as much. Improper fractionize them and multiply. So again, multiply, add 5 halves times multiply, add 7 halves. Nothing cancels here, so we have 35 fourths. And once again, you're not going to go over to your mom making a recipe and say, we need 35 fourths teaspoons of vanilla. No, sounds ridiculous. Go ahead and put it back into an improper fraction, and this time I will write a sentence. Joyce needs 4 into 35 goes 8 times with 3 left over. Joyce needs 8 3/4 teaspoons of, put an S on there, vanilla. One of my favorite tastes. All right, guys. Thanks for making it through the video. You're doing an awesome job in class. Remember to jot down the questions that you have, and I'll see you guys in class.